Hello, students. Good afternoon, good evening, good morning, whenever it is you're watching. You're back again to study chemistry with Miss Hernandez at La Jolla High School. And today we're covering section 4.6, Dalton's atomic theory. Remember, guys, that your packet, whatever you see here, is exactly what is in the presentation that we're going to be covering. I just made it more interactive, mostly for my students who are live. Okay. So it is exactly what you see in CK12 Flexbooks. Make sure that you are answering the questions on here. That way, all your answers are on one page. Okay. Remember, today we have moved Wednesday to Thursday. So this is the section that we're covering today, 4.6. Let's get this party started. Alrighty. Introduction. And it says it talks about a song. Pick a little, talk a little, pick a little, talk a little, chip, 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 talk a lot, pick a lot, a little more. All right. So let's read. What about these lyrics? Who's gonna read? Fifth period. I'm working with fifth period today, just like usual.
These lyrics from the Music Man sum up the way science was done for centuries. Okay, the lyrics referred to a group of gossiping ladies, but the outcome was the same. The Greek and Roman philosophers debated, discussed, and sometimes even attacked one another. But the mode of discovery was top. There was an experimentation, the idea that had not been thought of yet, so science did not develop very far, and there was no reliable way to establish what was true and what was false.
Thank you, Alexia. So we've already talked about Greek and Roman society, and we said that early on they hadn't thought of the idea of experimentation and research. So when it came to their theorizing, their wondering about the world around them and the matter around them, they did a lot of debate and discussion. And a lot of this debate and discussion had no scientific backing. Okay? There was no scientific research that supported one person over another. It was just about debating. Okay? And the reason why it's coming up today is because Dalton, after Democritus, was one of the first major scientists to do some experimentation and studying throughout his life that led to a lot of recognition for his work in the scientific community. Okay, so back then, the Romans and the Greeks, they did a lot of talking, a lot of debating, but not a lot of research. It wasn't until the time of John Dalton that people started to do more background and studying and research when it came to, you know, what people were trying to discover, what they wondered about the world and about the matter around them. Okay, so let's talk a little bit more about Mr. John Dalton. All right, so here I have a picture of a very young man in a science jacket. You have a picture of a school, and you have Manchester, the city in England, in the United Kingdom. Well, it must be assumed that many more scientists, philosophers, and others were studying the composition of matter after the Greek philosopher, our first Greek scientist, Democritus. Um, a major leap forward in our understanding of the composition of matter took place in the 1800s, and all due to the work that was being done by British scientist John Dalton. And let's just do a little bit of background information. So, who was John Dalton? Well, he started teaching school at a very young age, at the age of 12. He was primarily known as a teacher or professor. In his 20s, he decided to move to the growing city of Manchester, where he was able to, he was a scientist. He was a very important scientist. He was able to pursue some very important scientific studies. Now, a lot of his work, brought him a lot of his work in several areas of science was able to bring him to be recognized for his work, and he was able to receive a bunch of honors during his time on earth. And he was so famous in the city of Manchester that over 40,000 people marched or attended his funeral. So he was a really popular guy. By the time he passed away in Manchester, that there was a lot, almost 50, 40,000 people at your funeral. That's a lot of people. Okay. Um, so let's see. We have one question on the next slide. All right. It says here, write one fact that you recall about John Dalton from the previous slide. And it can be about anything regarding John Dalton that we just mentioned. Anything. All right. I'll give you some time to think. Because only 1 out of 6 people have answered. Alexia, what do you remember about what we just discussed about John Dalton? Because I know you're not in the pear deck. Or no, you are in the pear deck, so never mind. You're fine. Just answer in the pear deck. What do you remember about John Dalton? What did he do as a career? What did he do as a scientist? Was he recognized? Was he not recognized? Where did he live? We talked about the city he lived. We talked about the country he came from. So there's a lot of things that you can say about Mr. Dalton, and I still have only one response on Pear Deck. Come on, guys. What can you remember about John Dalton? What can you remember about Mr. Dalton? Two people have answered. I need at least 3 responses. Remember, it could be about anything that you remember that we just talked about from the previous slide. I don't want you checking the internet and finding out other things. I want to know, how well were you listening? All right, 3 people have responded. Let's check it out. All right, he was a famous scientist, and he was recognized for his work. Very good. He was a professor. He plays for the Cowboys. It's not John Dalton, it's Andy Dalton. But that's a good one. He was a big scientist. Very good. He was a very famous scientist. Very, very good. This one about the Cowboys is funny. That's a good one, either way. How did I know that was you, Oscar? I had a feeling that was you. All right, let's talk about his work and his studies in the science world. So John Dalton studied the weights of various elements. Okay, that was one thing he did. He noticed that matter always combined in fixed ratios based on weight or volume if you're talking about gases. Now, he also his research provided support for the law of definition of definite proportions. And remember, that states that chemical compounds always contain the same amount or proportions of elements by mass, regardless of the amount, which of course led to further support for the law of definite proportions, which was proposed by Proust. Dalton also observed that there could be more than one combination of 2 elements, right? Just because you're bringing 2 elements together doesn't mean that, yeah, it creates a compound, but if you have different amounts of each element, that creates different compounds. So I can totally understand that last observation that he made. All right, let's see if you're awake. Are you guys awake? Because we got another question. Is this statement true. And we're talking about the law of definite proportions. So this should look very familiar because we talked about it yesterday. Chemical compounds always contain different proportion of elements by mass regardless of the amount, which provided support for the law of definite proportions. Is that true or is that false? 2 people have answered. I need more than 2 responses. Come on, guys. Give me a little bit more responses than 2. All right, I got 3. Let's get at least 4 answers in. Who's my 4th student that's going to answer true or false? Chemical compounds always contain different proportion of elements by mass regardless of the amount. And this was supporting the law of definite proportions, which is what we talked about yesterday. Let's see. All right, so we have 4 people who chose true. Let's go back and let's figure out if that is a true or false statement. All right. It says it here in the middle of the paragraph. Chemical compounds always contain the same proportions, not different, the same proportions. So guys, this is a false statement because it says different right here. It's not different. It's supposed to be the same. Oh, now everybody jumps to the other side. You guys are funny. All right, now let's go into his theory. And there is part of the theory that is true. There's part of the theory that's false. Let's see if you can recognize which bullet point is not true anymore. Okay? From his experiments and observations, as well as the work from his peers of his time, Dalton proposed a new theory of the atom. This later became known as Dalton's atomic theory. The general points, the tenets of this theory were as follows, okay? So first, bullet point number 1. All matter is composed of extremely small particles called atoms. I think that's true. That is true. Very true, right? Bullet point number 2. Atoms of a given element are identical in size, mass, and other properties. Atoms of different elements have different size, mass, and properties. Very good. I agree with some of that statement. Number 3, atoms cannot be subdivided, created, or destroyed. Number 4, atoms of different elements can combine in simple whole number ratios to form chemical compounds. I think that's true because I don't think I've ever seen a decimal point in a formula. Have you ever seen a decimal point in a formula? 4.2 hydrogens or H 4.2 O 3.5. I've never seen a decimal point in a formula. I've never seen a fraction in a formula. So I would say that one, yeah, I completely agree with that one. And then bullet point 5. In chemical reactions, atoms are combined, separated, and rearranged. Combine is synthesis reaction. That happens. Separated is a decomposition reaction. That happens. And atoms get rearranged in double and single replacement reactions. So most of those statements are true. There are a couple that may be a little shady. Okay? Drag your dot to indicate whether you agree or disagree. So this is kind of like the true and false question. Okay? Now, tell me if you agree with what John Dalton supposedly said. All matter is composed of extremely small particles called elements. Do you agree or disagree? Pick a point. Do you agree or do you disagree? Oh, I'm sorry. I'm so sorry for yawning like that. I miss Libby. True or false? Agree or disagree? Let me get at least 2 more answers in the pair deck. I want 5 responses. I only have 3 right now. If you are in the pair deck, agree or disagree with this statement, please. Agree or disagree with this statement, please. All right, let's check it out. Let's check it out. 3 people agree. 4 people agree. Nobody disagrees with this statement. All right, let's go back to the last slide. Look at bullet point number 1. Oscar, read it for me.
All matter is composed of extremely small particles called atoms.
So, what is the correct answer? Disagree. They're called atoms. They're not called elements. Come on, guys. I thought you would have gotten this one right. Good job.
I put disagree first, miss.
All right. Good job. All right. Now let's talk about, for the most part, scientists now agree with Dalton, except for 3 points. Dalton's atomic theory has largely been accepted by the scientific community. So a lot of people gave him, most of it, a thumbs up. It's good to go. Except there was 3 changes that they would have liked. Number 1, an atom can be further subdivided, right? That's how come we have the atomic bomb. 2, all atoms of an element are not identical in mass. Guys, all these elements on our periodic table, they don't actually exist. The only thing that does exist are isotopes. And we take information from isotopes to come up and to create all of those numbers that you have on the periodic table. Carbon has 3 isotopes. Carbon 12, 13, carbon 14. How much does it weigh? 12, 13, and 14. Do they all have 6 protons? Yes, they all have 6 protons and 6 electrons. The only thing that makes these different, way different, are the neutrons. Okay? Are the neutrons. And that makes the mass different. Okay? Those neutrons, they make mass different. Number 3, using nuclear fission and nuclear fusion techniques, we can create or destroy atoms by changing them into other atoms. All right. I don't know if you remember when we talked about elements in week 7 and we started talking about all those new elements that got added. A lot of those new atoms that got added, they are not real. Okay? They are a combination of elements. They connect them together. They create something new, but that something new separates and gets destroyed right away. Okay? These new compounds are not stable enough to be researched. So we don't know a lot about them. Okay? Okay, so then that's it. Those are the 3 bullet points. The only thing that's left to do is watch a video. And I'm going to forward some of the video, at least a minute and a half, because he talks about all these other laws that I don't want to confuse you with. And it is on YouTube, so bear with me. It's going to play a commercial real quick.
All right, so here we're going to go over Dalton's atomic theory.
Okay, I'm going to go forward.
If we have 2 compound
About
element,
a minute.
there are some differences between Dalton's. We're also going to go over theory.
All right, there.
So the first part of Dalton's atomic theory says that all matter is composed of atoms, and that atoms are indivisible and indestructible. And this fact was accepted for a very, very, very long time after Dalton came up with this theory. But as technology, increased and newer techniques became available of, separation, it became known that the atoms are actually composed of subatomic particles, like protons, neutrons, electrons, things like that. And in nuclear chemistry, if you carry out a nuclear reaction, you can also destroy an atom. So in a chemical reaction, you can't destroy an atom, but in a nuclear reaction, you can. So that's just sort of a small difference between Dalton's theory and today's theory. So let's go over the second part. Second part says that all atoms of a given element have the same mass and other properties that distinguish them from other atoms. Now, while the second part of this sentence is true, that all atoms of a given element have properties that distinguish them from other atoms, it's not necessarily true that they all have the same mass. In fact, there do exist atoms of the same element that have different mass, and we call those isotopes. They differ only in the number of neutrons. And today, the way that we characterize an element is we say that instead of all atoms of a given element have the same mass, we say that all atoms of the same element, all atoms of a given element have the same atomic number, which is simply the number of protons in the nucleus of that atom. So, a little bit different now, but like I said, pretty remarkable at the time. Let's go over the third part. The third part says that atoms combine to form compounds in simple whole number ratios. That is still true today. Now let's go over the fourth part. The fourth part says that an atom of one element cannot change into an atom of another element. Chemical reactions involve simply the rearrangement of atoms. So the way that atoms are bound together changes in a chemical reaction, but the atoms are not changed from one atom to another, is what Dalton was trying to say here. And this is, this is actually sort of an oversimplification as well, because, again, when we consider nuclear chemistry, in a nuclear reaction, indeed, an atom can change into another type of atom. It can capture, some other subatomic particle from somewhere, and, you can have a carbon, that turns into a nitrogen. That is possible with a nuclear reaction, but not in a chemical reaction. So Dalton's atomic theory applies mainly to chemical reactions. So there you have it. That is Dalton's atomic theory.
All right. So in case you didn't understand my version of my explanation, there was a second.
One of the great challenges.
Okay. All right. Let's finish the pair deck. Dalton proposed, or this is the summary of today's topic. Dalton proposed his atomic theory in 1804. The general statements of this theory were as follows. All matter is composed of extremely small particles known as atoms. Atoms of a given element are identical in size, mass, and other properties. Atoms of different elements differ in size, mass, and properties. Atoms cannot be subdivided, created, or destroyed. Atoms of different elements are combined in simple whole number ratios to make compounds. In chemical reactions, atoms are combined, separate, or rearrange. You have 3 review questions. Number 2 is super easy. It's a fill in the blank. But number 1 says, did Dalton believe that atoms could be created or destroyed? Number 2, according to Dalton's theory, all atoms of the same blank are identical in size, mass, and other properties. And number 3, what part of the theory are not considered valid anymore? Okay. All right. Those are your questions. Please work on